Langchain Cohere Re-rank. A re-ranking technique using Cohere's application programming interface to reorder a list of text documents based on their relevance to a query. Re-ranks a list of documents based on their relevance to a query using Cohere's application programming interface. Inputs: a list of text documents to be re-ranked. For example, you might have a list of articles about a particular topic, and you want to reorder them based on how relevant they are to a specific search query. A query that the documents are to be ranked against, for instance. If you have a list of articles about artificial intelligence, and your query is the history of artificial intelligence, the documents will be ranked based on their relevance to the history of artificial intelligence. Outputs: a list of documents, re-ranked based on their relevance to the query. This means that the documents that are most relevant to the query will appear at the top of the list, while the least relevant documents will appear at the bottom. Steps: the documents are sent to the Cohere application programming interface. This means that the documents are sent to a server that runs the Cohere application programming interface. The Cohere application programming interface calculates the relevance of each document to the query. The Cohere application programming interface uses a machine learning model to determine how relevant each document is to the query. The documents are returned in order of decreasing relevance. The documents that are most relevant to the query will appear first, followed by the documents that are less relevant. Prerequisites: Cohere application programming interface key. This is a unique identifier that allows you to access the Cohere application programming interface. Cohere application programming interface endpoint. This is the address of the server that runs the Cohere application programming interface. Fine-tune parameters. Model type. This refers to the machine learning model that is used to calculate the relevance of the documents. Different models may be better suited for different tasks. For example, some models are better at understanding natural language, while others are better at understanding code. Number of results. This refers to the number of documents that you want to be returned. For example, you might want to return the top 10 most relevant documents, or you might want to return all of the documents. Challenges and fixes. The Cohere application programming interface may be unavailable. This could be due to a temporary outage or a problem with the server. Retry the request later. You can try sending the request again after a few minutes or hours. The Cohere application programming interface may return an error. This could be due to a problem with the request, or it could be due to a problem with the Cohere application programming interface itself. Check the application programming interface documentation for error codes. This will help you understand what the problem is and how to fix it. Langchain coherent re-ranking. Re-ranking retrieved documents based on relevance to a given query using Cohere, a large language model, to improve the accuracy and efficiency of information retrieval. Inputs: textual query that a user wishes to answer using a set of documents. For example, what are the benefits of using langchain? A set of documents retrieved based on a specific search query. These documents are often retrieved from a variety of sources, such as a database or the web. Outputs: a set of documents re-ranked according to their relevance to the query, with the most relevant documents appearing first. Steps: retrieve documents based on the query using a search engine or a document retrieval system. This involves identifying documents that are likely to contain information relevant to the query. Use Cohere, a large language model, to re-rank the retrieved documents based on their relevance to the query. This involves feeding the query and the retrieved documents to Cohere and letting the model Determine the order of relevance for the documents. Prerequisites. Cohere Application Programming Interface key is required to access the Cohere application. Programming Interface API. This key is specific to a user's account and grants access to Cohere's services. Langchain is a Python framework that allows developers to build applications using large language models like Cohere. Langchain provides tools and integrations to manage the workflow of retrieving, processing, and re-ranking documents using Cohere. Fine-tune parameters. The specific Cohere model to be used for re-ranking. Cohere offers various models with different strengths and weaknesses. Selecting the appropriate model depends on the specific requirements of the task. The number of top documents to be considered for re-ranking. This parameter determines the size of the subset of documents that will be re-ranked by Cohere. Challenges and fixes. Errors encountered when accessing the Cohere Application Programming Interface API. These errors can occur due to an invalid or expired Application Programming Interface API key, network connectivity issues, or other problems with the Cohere service. Verify that the Application Programming Interface API key is valid and has not expired. Ensure a stable network connection and check the status of the Cohere service. Re-ranking may not be effective if the Cohere model is not appropriate for the specific task or if the retrieved documents are not relevant to the query. Adjust the Cohere model or the top K parameter based on the specific requirements of the task. Experiment with different models and parameter values to find the optimal configuration for re-ranking. Langchain Elasticsearch Chat History Summarization. A description of how to store conversational history in Elasticsearch using Langchain. This document describes a method for storing conversational history in Elasticsearch using Langchain. Langchain is a framework for building applications that use language models. Elasticsearch is a search engine that can be used to store and retrieve data. By storing conversational history in Elasticsearch, you can easily search and retrieve past conversations, which can be useful for building chatbots, customer support applications, and other applications that require access to conversational history. Inputs. The user input is the text that is entered by the user. The previous conversation history is the collection of all previous user inputs in chatbot. Responses. Outputs. The conversation history in Elasticsearch is a record of all user inputs in chatbot responses. Steps. Initialize Langchain. Langchain is a framework for building applications that use language models. You will need to initialize Langchain before you can use it to store conversational history in Elasticsearch. Define Elasticsearch Index. An Elasticsearch index is a collection of documents that are stored in Elasticsearch. You will need to define an Elasticsearch index to store the conversational history. Store conversation history. Once you have initialized Langchain and defined an Elasticsearch index, you can start storing conversational history. Prerequisites. Elasticsearch installation. Before you can store conversational history in Elasticsearch, you need to install Elasticsearch. This command downloads the Elasticsearch Docker image and runs it on your machine. The command maps port 9200 on your machine to port 9200 on the Elasticsearch container. This makes Elasticsearch accessible on your machine. The command also maps port 9300 on your machine to port 9300 on the Elasticsearch container. This makes Elasticsearch accessible for communication between Elasticsearch nodes. The command also sets the discovery type to single node, which means that Elasticsearch will run in a single node cluster. The command also specifies the version of Elasticsearch to use. Python libraries. You will also need to install the langchain and Elasticsearch Python libraries to store conversational history in Elasticsearch. Langchain is a framework for building applications that use language models. Elasticsearch is a search engine that can be used to store and retrieve data. The langchain library provides a way to interact with Elasticsearch from Python. Fine-tune parameters. Elasticsearch index name. You can specify the name of the Elasticsearch index that you want to use to store a conversational history. The name of the index should be descriptive and easy to remember. Elasticsearch host and port. You can specify the host and port of the Elasticsearch instance that you want to use to store a conversational history. The host and port of the Elasticsearch instance should be accessible from your application. Challenges and fixes. Elasticsearch connection issues. If you are unable to connect to Elasticsearch, you may encounter connection issues. This could be due to a number of factors, including a misconfigured Elasticsearch instance, network connectivity problems, or incorrect Elasticsearch credentials. You can troubleshoot Elasticsearch connection issues by checking the Elasticsearch instance to make sure that it is running and listening on the correct port. You can also verify the network connectivity to make sure that your application can communicate with Elasticsearch. Finally, you can check the Elasticsearch credentials to make sure that they are correct. Indexing errors. If you encounter indexing errors, it could be due to a number of factors, including an invalid Elasticsearch schema, incorrect data format, or improper indexing configuration. You can troubleshoot indexing errors by reviewing the Elasticsearch schema to make sure that it is valid and that the data you are indexing is in the correct format. You can also verify the indexing configuration to make sure that it is correct. If you are still encountering indexing errors, you can consult the Elasticsearch documentation for more information on troubleshooting indexing errors. Langchain Elasticsearch Cache Summary. A detailed description of the Langchain Elasticsearch Cache, explaining its purpose, functionality, and use cases. Inputs. The Langchain chain that will be cached. This refers to a sequence of components within Langchain, such as prompts, models, and functions, designed to perform a specific task. For example, a chain could be used to summarize a text document or to translate text from one language to another. The Elasticsearch index to store the results in. Elasticsearch is a powerful search and analytics engine. An index is a collection of documents that are indexed and stored in Elasticsearch. By storing results in an Elasticsearch index, you can efficiently search and retrieve them later. Outputs. The results of the Langchain chain. These results can be anything that the chain outputs, such as text, data, or objects. They are stored in the Elasticsearch index, allowing for efficient retrieval and reuse. Steps. Define a Langchain chain that will perform the desired computation. This involves defining the specific components and their order within the chain. For instance, you might define a chain that first extracts relevant information from a document, then summarizes it, and finally translates the summary into another language. Create an Elasticsearch index to store the results. This involves configuring Elasticsearch to store the results of your Langchain chain. You'll need to define the schema and data types for the index to ensure that the results are properly stored and searchable. Create a Langchain Elasticsearch cache instance, providing the chain and the index. This step establishes a connection between your Langchain chain and the Elasticsearch index. The cache instance acts as an intermediary, storing and retrieving results from the index. Run the chain, using the cache instance to store and retrieve results. Once your chain is defined and the cache instance is created, you can run the chain. The cache instance will automatically check the Elasticsearch index for existing results before running the chain. If the results are already cached, they will be retrieved from the index. Otherwise, the chain will be executed, and the results will be stored in the index for future use. Prerequisites: Elasticsearch installed and running. Elasticsearch is an open-source search and analytics engine that can be installed and run on various operating systems. You can install Elasticsearch by following the official documentation provided by Elasticsearch. Langchain installed. Langchain is a powerful library for building and connecting language models. You can install Langchain using pip, a package installer for Python. The command to install Langchain is pip install langchain. Fine-tune parameters. Index name. This parameter specifies the name of the Elasticsearch index where the results will be stored. This name must be unique within your Elasticsearch cluster. It's good practice to use a descriptive name that reflects the purpose of the index, making it easier to manage and understand. Cache key prefix. This parameter allows you to specify a prefix for the keys used to store and retrieve results in the Elasticsearch index. This can help organize and group your cache entries, particularly if you are using the same Elasticsearch index for multiple LangChain chains or for different types of results. Challenges and fixes. Slow performance due to Elasticsearch network latency. Network latency can significantly impact the performance of Elasticsearch. If your Elasticsearch instance is located on a remote server, network latency can slow down cache operations. To address this, you can try optimizing Elasticsearch configuration, reducing network latency by using a local Elasticsearch instance, or exploring alternative caching solutions that may be more suitable for your specific requirements. Elasticsearch index size limit. Elasticsearch indices have a size limit, and as the index grows, it can consume more disk space and potentially impact performance. To handle this, you can explore more efficient indexing strategies, such as using compressed data formats or regularly purging old data. Additionally, you can consider using a different caching solution that might be better suited for handling large amounts of data. LangChain Elasticsearch Cache. Elasticsearch Cache Summary. A LangChain Elasticsearch cache is a method to store and retrieve data in the form of embeddings or other data from an Elasticsearch index. Inputs. Embeddings are numerical representations of text or other data that capture the semantic meaning of the data. Embeddings are often used in machine learning tasks, such as natural language processing and computer vision. A query is a request for information from a database or other information retrieval system. In the context of a LangChain Elasticsearch cache, a query would be a request to retrieve embeddings or other data from an Elasticsearch index. Outputs. Embeddings are the numerical representations of text or other data that capture the semantic meaning of the data. Embeddings are often used in machine learning tasks, such as natural language processing and computer vision. Results are the data that is retrieved from the Elasticsearch index in response to a query. Results might include embeddings, documents, or other information. Steps. Store embeddings in Elasticsearch involves adding the embeddings to an Elasticsearch index. Retrieve embeddings and data from Elasticsearch is the process of fetching embeddings or other data from an Elasticsearch index in response to a query. Prerequisites. An Elasticsearch instance is a server that runs Elasticsearch, a search and analytics engine. The instance must be accessible to the LangChain application. Elasticsearch URL. Index name. and document type are the required parameters to connect to a specific Elasticsearch index. The langchain library is a Python library that provides tools for building and deploying language models and applications. The pip install langchain command installs the langchain library on your system. Fine-tune parameters. Elasticsearch connection parameters are settings that specify how to connect to an Elasticsearch instance. These settings include the Elasticsearch URL, authentication credentials, and other connection details. Indexing settings are parameters that control how data is indexed in Elasticsearch. These settings include the number of shards, the number of replicas, and the indexing strategy. Challenges and fixes. Large index size can impact the performance of the Elasticsearch index. Consider using a dedicated Elasticsearch cluster with more resources to handle large indices. Performance issues may arise from slow indexing or retrieval operations. Optimize indexing and retrieval settings to improve performance. Langchain Elasticsearch Client. Create Elasticsearch Client. This action creates a client object that enables interaction with an Elasticsearch server. This client object can be used for various tasks, including searching, indexing, and managing data within your Elasticsearch database. Inputs. This represents the URL of the Elasticsearch server. For example, it could be http localhost 9200 for a locally hosted Elasticsearch instance. This specifies the specific Elasticsearch index that you want to work with. An index is essentially a collection of documents within your Elasticsearch database. For instance, you might have an index named products to store information about different products. Outputs. This output is the Elasticsearch client object. This object serves as your interface to the Elasticsearch server. Through this object, you can send requests to the Elasticsearch server to perform various operations. Steps. This involves establishing a connection to the Elasticsearch server using the provided host URL. This connection is essential for all subsequent interactions with the server. Once connected, you need to specifically target the desired Elasticsearch index. This step enables you to work with the data contained within the chosen index. Prerequisites. This involves installing the Elasticsearch Python client library. This library provides the necessary tools and functions to interact with Elasticsearch from your Python code. This installation can be done using the pip package manager command pip install Elasticsearch. You need an active and running Elasticsearch server. Elasticsearch is a powerful search and analytics engine that requires its own separate installation. It must be operational before you can create a client to interact with it. Fine-tune parameters. This represents the port number on which the Elasticsearch server is listening. While the default port is 9200, you can configure Elasticsearch to use a different port if needed. If your Elasticsearch server is configured with user authentication, you need to provide the appropriate username and password. This allows the client object to access the server securely. Challenges and fixes. This can occur if the provided host URL or port number is incorrect. It can also happen if the Elasticsearch server is not running or is inaccessible due to network issues. To resolve this, verify the accuracy of the host URL and port number. Ensure that the Elasticsearch server is running, and check for any network connectivity problems. This usually happens when the specified index name is invalid or if the index does not exist. To address this, double-check the index name for correctness. If the index does not exist, create it within your Elasticsearch database using the necessary commands or API calls. Langchain Elasticsearch Client. Create Elasticsearch Client. This step describes the process of creating an Elasticsearch client, a key component for interacting with Elasticsearch, a powerful open-source search and analytics engine. Inputs: the Elasticsearch URL. This is the address of your Elasticsearch server, specifying the protocol HTTP or HTTPS. Host and port. For example, it might look like HTTP localhost 9200. Authentication credentials. These are the security details needed to access your Elasticsearch cluster. They typically include a username and password, which are used to authenticate with the Elasticsearch server. Outputs: Elasticsearch client object. This is a Python object that represents your connection to the Elasticsearch server. It provides methods for interacting with Elasticsearch, such as searching for documents, creating indices, and updating data. Steps: import required libraries. This involves importing the necessary Python libraries that allow you to connect to and interact with Elasticsearch. The most common library is the Elasticsearch Python client. Instantiate Elasticsearch client with provided credentials. You create an instance of the Elasticsearch client object, providing the Elasticsearch URL and authentication credentials, username and password. Prerequisites: install Elasticsearch. This step involves downloading and installing the Elasticsearch software. This sets up the Elasticsearch server, which is the core component that handles data indexing, searching, and analysis. You can download Elasticsearch from the official website and follow the installation instructions. Download and install Elasticsearch. This is the process of obtaining the Elasticsearch distribution from the official website and running the installation script, which will configure Elasticsearch on your system. Install Elasticsearch Python client. This involves installing the Elasticsearch Python client using the pip package manager. This library provides the necessary functions and classes to connect to and interact with your Elasticsearch server from your Python code. Use pip install Elasticsearch. Run the command pip install Elasticsearch in your terminal. This will download and install the Elasticsearch Python client from the Python package index pypi. Fine-tune parameters. Elasticsearch client options. These are configuration settings that can be applied to the Elasticsearch client object, allowing you to tailor its behavior. Examples include setting timeouts, connection pools, and logging levels. Elasticsearch index configuration. This refers to the settings and mappings that define how your data is indexed and stored in Elasticsearch. It includes defining the fields, data types, and analysis settings that control how Elasticsearch understands and processes your data. Challenges and fixes. Incorrect Elasticsearch URL. This issue occurs when the provided URL is invalid or points to a non-existent Elasticsearch server. Verify URL format and connection. Check that the URL is correctly formatted and that you can establish a connection to the specified host and port. You can use tools like curl or browser-based tools to test the connectivity. Authentication errors. These errors occur when the provided authentication credentials are incorrect or lack the necessary permissions to access the Elasticsearch server. Check credentials and verify access permissions. Review the username and password to ensure they are correct and that the user account has the required access rights to the Elasticsearch cluster. If you are using a security framework like LDAP or Active Directory, ensure the connection details are set up correctly. Langchain Elasticsearch Chat History. Elasticsearch Chat Message History. Description of the langchain Elasticsearch Chat History. Elasticsearch Chat Message History class. Inputs. List of chat messages. Each message has a role, system, user or assistant. For example, role system. Content: this is a system message. Role: user. Content: what is the capital of France? Role: assistant. Content: the capital of France is Paris. Elasticsearch index: name the name of the Elasticsearch index to store the chat history. For example, chat history index. Outputs: list of chat messages. Each message has a role, system, user or assistant. Steps: initialize a new Elasticsearch chat message history object. This object is used to store and retrieve the chat history from Elasticsearch. Add each chat message to the history object. Each chat message is added to the history object, along with its role, system, user or assistant. Store the history object in Elasticsearch index. The history object is stored in the Elasticsearch index, which is specified by the index name. Retrieve the chat history from Elasticsearch. The chat history is retrieved from the Elasticsearch index using the index name. Prerequisites: Elasticsearch client. For example, Elasticsearch DSL, a Python client that can interact with an Elasticsearch cluster. Elasticsearch index. For example, chat history index. The Elasticsearch index is where the chat history is stored. It must be created with appropriate mappings to handle the chat message data. Fine-tune parameters. Index name: the name of the Elasticsearch index where the chat history is stored. Document type: the document type of the chat history data stored in Elasticsearch. Challenges and fixes. Chat history index size exceeds Elasticsearch limit. For example, 10 GB. Split the chat history into multiple indices to avoid exceeding Elasticsearch's limit on index size. Chat history retrieval performance is slow. For example, several seconds. Optimize Elasticsearch index settings to improve chat history retrieval performance. For example, use appropriate shard and replica settings. And index the most frequently accessed data first. Elasticsearch installation. Install and configure Elasticsearch. Elasticsearch needs to be installed and configured on your system. This involves setting up the required dependencies, configuring the Elasticsearch server, and defining any custom configurations needed for your specific application. Embedding model. Choose an embedding model suited for the task. Selecting the right embedding model is crucial for effective semantic search. Different models excel at capturing different aspects of meaning, and choosing the appropriate one for your specific task is vital. Factors to consider include the size of your dataset, the complexity of the language, and the type of semantic relationships you want to capture. Langchain integration. Install and configure langchain with Elasticsearch support. Langchain, a powerful library for building applications using large language models, provides integrations with Elasticsearch. You need to install the necessary langchain components and configure them to connect to your Elasticsearch instance. This allows you to seamlessly integrate langchain's capabilities with Elasticsearch for efficient vector storage and retrieval. Fine-tune parameters. Embedding model. Fine-tune an embedding model for better performance. For optimal results, you can fine-tune your chosen embedding model on your specific dataset. This involves training the model on a subset of your data to adapt it to the nuances and specific vocabulary of your domain. Fine-tuning allows the model to learn better representations of your text, leading to more accurate semantic search results. Elasticsearch index configuration. Optimize Elasticsearch index settings for efficient search. Elasticsearch index configuration plays a critical role in search performance. You can optimize settings such as the number of shards, replicas, and the indexing strategy to ensure efficient retrieval of documents based on their embeddings. Tuning these settings based on your data volume. Query patterns. and hardware resources can significantly improve the speed and accuracy of your semantic search. Challenges and fixes. Memory constraints. Use vector quantization techniques to reduce storage requirements. Storing large numbers of embeddings can be memory intensive. Vector quantization techniques can be used to compress the embeddings, reducing the storage requirements without significant loss of semantic information. These techniques approximate the original embeddings with fewer bits, allowing for efficient storage and retrieval. Search performance. Tune Elasticsearch settings and indexing strategies. Search performance can be impacted by factors like index size, query complexity, and hardware resources. Tuning Elasticsearch settings, such as the number of shards, replicas, and the indexing strategy, can significantly improve the speed of semantic search. Experimenting with different strategies and configurations can help optimize search performance based on your specific needs. Embeddings quality. Experiment with different embedding models. The quality of embeddings directly affects the accuracy of semantic search. Experimenting with different embedding models can lead to significant improvements in the retrieved results. Exploring models designed for specific tasks, such as capturing fine-grained semantic relationships or handling different languages, can enhance the overall performance and accuracy of your system. Langchain Elasticsearch Retrievers. A detailed description. This section details the functionalities of using langchain with Elasticsearch to access and retrieve information from Elasticsearch indices. Inputs. A search query or a prompt that defines the user's information request. For example, what is the capital of France? The specific Elasticsearch index name where the relevant data is stored. For instance, countries index. Outputs. A list of documents from the Elasticsearch index that are determined to be relevant to the given search query or prompt. Steps. Establish a connection to the Elasticsearch server by initializing an Elasticsearch client. Define a langchain Elasticsearch retriever object. This object utilizes the Elasticsearch client to interact with the specified Elasticsearch index. Submit the provided search query to the langchain Elasticsearch retriever. Retrieve documents from the Elasticsearch index that best match the search query based on pay. Retriever's search capabilities. Prerequisites. The Elasticsearch server must be running and accessible. The server typically runs on the default address localhost and port 9200. An Elasticsearch index must exist that contains the relevant data to be searched. This index should be populated with data related to the search queries or prompts. Fine-tune parameters. Size represents the number of documents that the retriever should attempt to retrieve from pay Elasticsearch index during a search operation. K refers to the number of top results documents that should be returned to the user based on their relevance to the search query. Embedding function is a function used to generate numerical representations embeddings of pay documents in the Elasticsearch index. This embedding function is crucial for determining the similarity between the search query and pay documents. Challenges and fixes. Slow retrieval times can occur if the Elasticsearch index is large or if the embedding function is computationally expensive. To improve retrieval speed, consider optimizing the Elasticsearch index structure and using a faster embedding function that requires less computational resources. The retrieval of irrelevant documents might happen if the search query is poorly defined or if pay Elasticsearch index structure is not well suited for the search task. To address irrelevant retrieval, refine the search query to be more specific and accurate. Additionally, consider revising the Elasticsearch index structure to better align with the data being searched. For instance, You might want to add more relevant fields or improve the indexing process to ensure the index accurately reflects the content. Langchain Elasticsearch Client. Create Elasticsearch Client. This description details the process of creating an Elasticsearch client using langchain, a framework for building and deploying language models. It includes the necessary steps, prerequisites, and potential challenges. Inputs: the URL of the Elasticsearch server where the client will connect. This URL usually includes the host name or IP address and the port number. For example, http://localhost 9200. Authentication credentials required to access the Elasticsearch server. These typically include username and password, or an API key, depending on the server's security configuration. Outputs: an Elasticsearch client object that can be used to interact with the Elasticsearch server. This client provides methods for performing operations such as indexing documents, searching, and retrieving data. Steps: initialize an Elasticsearch client using the langchain library, passing in the URL and authentication details. This involves creating an instance of the Elasticsearch client class and configuring it with the provided parameters. Prerequisites: an Elasticsearch server running and accessible. This involves installing and configuring the Elasticsearch software, ensuring it is listening on the specified port and is configured with appropriate security settings. A typical Elasticsearch server runs on the default port 9200. This URL is used to connect to the Elasticsearch server. An Elasticsearch index that exists and is accessible by the client. This involves creating an index in Elasticsearch, which is a logical grouping of documents with similar properties and content. The My index is an example of a specific Elasticsearch index. Fine-tune parameters. Parameters that can be configured to fine-tune the behavior of the Elasticsearch client. These parameters might include connection timeout, retry attempts, or specific index settings. Timeout refers to the maximum amount of time the client will wait for a response from the server before considering the operation to have failed. Challenges and fixes. Issues connecting to the Elasticsearch server. This might be due to the server being down, network connectivity problems, or incorrect authentication details. The solutions include verifying the Elasticsearch server is running, checking network connectivity, and ensuring the provided authentication details are correct. The specified Elasticsearch index does not exist. This could be because the index was not created or was accidentally deleted. Possible fixes include creating the index in Elasticsearch or updating the client to connect to a different existing index. Langchain Elasticsearch Chat History Summarization. A structured description of the langchain Elasticsearch Chat History Summarization component. This component allows you to store and retrieve chat history data from Elasticsearch, a popular open-source search and analytics engine. This enables persistent storage of conversations, which can be useful for various purposes, such as analyzing user interactions, improving chatbot performance, or providing context for future conversations. Inputs: users' chat messages. The messages sent by the user to the chatbot, including text, images, or other media. Real-world example: user might say, "Hello, what's the weather like today?" Chatbot's responses: the responses generated by the chatbot, based on the user's input and any relevant context. Real-world example: the chatbot might reply, "The weather today is sunny and 75 degrees Fahrenheit." Outputs: chat history data stored in Elasticsearch. The chat history data, including user messages and chatbot responses, is indexed and stored within Elasticsearch. This data is organized in a structured way, allowing for efficient querying and retrieval. Chat history data retrieved from Elasticsearch. The chat history data can be retrieved from Elasticsearch using specific queries to filter, sort, and retrieve relevant conversations. This retrieved data can be used for various applications, such as analyzing user behavior, improving chatbot responses, or providing context for future interactions. Steps: initialize Elasticsearch. Client establishes a connection to the Elasticsearch instance, allowing the component to interact with the search engine. This step ensures that the component can access and manipulate the data stored within Elasticsearch. Index chat history data into Elasticsearch. The chat history data, comprising user messages and chatbot responses, is transformed into a format suitable for indexing within Elasticsearch. This step involves defining the structure and schema of the data to ensure efficient storage and retrieval. Retrieve chat history data from Elasticsearch using appropriate query syntax. The component can retrieve specific chat history entries from Elasticsearch. This allows for targeted retrieval of conversations based on various criteria, such as specific users, time periods, or keywords. Prerequisites: Elasticsearch instance. An instance of Elasticsearch must be set up and running before a component can be used. Elasticsearch is an open-source search and analytics engine that is used to store and search large volumes of data. Installation guide: instructions for installing Elasticsearch on various platforms, including Linux, Mac OS, and Windows. Elasticsearch index: an Elasticsearch index must be created to store the chat history data. An index is a logical unit of organization within Elasticsearch, allowing for structured storage and retrieval of data. Index creation: documentation on how to create an Elasticsearch index, including specifying its properties and mapping for the chat history data. Fine-tune parameters: Elasticsearch index name: the name of the Elasticsearch index where the chat history data will be stored. Choosing a descriptive index name can help organize and manage multiple indices within a Elasticsearch instance. Mapping for chat history data defines the structure and data types of the chat history data within the Elasticsearch index. This mapping specifies how user messages, chatbot responses, timestamps, and other relevant information will be stored and indexed within Elasticsearch. Challenges and fixes: indexing large amounts of chat history as the amount of chat history data grows. Indexing performance can be affected. Use batch indexing instead of indexing individual chat history entries. Batch indexing groups multiple entries together for more efficient processing. This reduces the overhead of individual index requests and improves the overall indexing performance. Retrieving specific chat history entries: efficiently retrieving specific chat history entries, based on various criteria, is crucial for analyzing user interactions and providing contextual responses. Use Elasticsearch query syntax. Elasticsearch offers a powerful query language for searching and filtering data stored within indices. Performance optimization: for indexing and retrieval, optimizing Elasticsearch performance is essential for ensuring fast indexing and retrieval of chat history data. Optimize Elasticsearch cluster configuration: adjusting cluster settings, such as the number of shards and replicas, can significantly impact the indexing and retrieval performance. Security considerations for chat history data: protecting chat history data, which may contain sensitive user information, is paramount. Use Elasticsearch security features. Implementing Elasticsearch security features, such as role-based access control and data encryption, can help secure the chat history data from unauthorized access. Data persistence and backup: ensuring the durability and availability of chat history data is Critical. Implement Elasticsearch snapshotting regularly. Creating snapshots of the Elasticsearch index containing the chat history data helps protect against data loss and allows for restoring data to a previous point in time. Langchain Elasticsearch client. Create Elasticsearch client summary. This YAML file describes the process of creating an Elasticsearch client for retrieving documents from Elasticsearch. The process encompasses input requirements, output expectations, step-by-step procedures, prerequisites, fine-tuning parameters, and potential challenges with their respective solutions. Inputs. This step involves providing the necessary connection details to establish a connection with a Elasticsearch server. These details include the host address of the server, the port number for communication, the name of the Elasticsearch index to be accessed, and the authentication credentials, username and password if the Elasticsearch server is secured. This step involves configuring optional parameters to customize the document retrieval process. These parameters include 1. Query parameters, which specify the search criteria for retrieving documents. These parameters can be in the form of keywords, phrases, or more complex Boolean expressions. 2. Document field mappings, which define how the retrieved documents are structured and how individual fields are mapped to the desired format. 3. Retrieval settings, which control the number of documents to retrieve, the order of retrieval, e.g., relevance ranking, and pagination settings for retrieving large sets of documents. Outputs. The process of creating an Elasticsearch client generates an Elasticsearch client object. This object acts as a gateway to interact with the Elasticsearch server and perform operations such as searching, indexing, and updating documents. The process also generates retrieved document results. These results are presented in a formatted manner based on the predefined mappings, making them readily interpretable and usable for subsequent analysis or processing. Steps. This step involves initializing an Elasticsearch client object. This initialization requires providing the previously mentioned connection details, host, port, index, and authentication credentials to the Elasticsearch client library. The library then establishes a connection to the Elasticsearch server based on the provided information. This step involves configuring the various parameters mentioned in the input section. These include defining query parameters, specifying document field mappings, and configuring retrieval settings. These parameters are used to customize the search query and the formatting of the retrieved documents. This step involves executing a search query against the Elasticsearch server. The query is constructed based on the configured query parameters and is sent to the Elasticsearch server. The server then processes the query and retrieves relevant documents based on the search criteria. This step involves processing and formatting the retrieved document results. The document results are retrieved from the Elasticsearch server and are transformed based on defined mappings. This transformation ensures that the retrieved data is structured and presented in a user-friendly format for further analysis or use. Prerequisites. This step involves ensuring that an Elasticsearch server is running and is accessible. This accessibility should extend to the network where the Elasticsearch client is running. Moreover, the Elasticsearch Python library or the corresponding library for the chosen programming language needs to be installed on the client's system to enable the communication and interaction with the Elasticsearch server. This step involves ensuring that a valid Elasticsearch index name is provided. The provided index name should correspond to an existing index within the Elasticsearch server. Additionally, The user running the Elasticsearch client should have the necessary permissions to access this. Index. Fine-tune parameters. This step involves fine-tuning various parameters to optimize the retrieval of documents from Elasticsearch. These parameters include 1. Query string syntax, specifying the syntax for constructing the search query, ensuring that it adheres to the supported query language of Elasticsearch. 2. Field mappings, defining the mappings between fields in the retrieved documents and their corresponding representations in the output format. 3. Retrieval limits, specifying the maximum number of documents to be retrieved per request, to manage the volume of data returned and the processing time. 4. Pagination settings, configuring the pagination mechanism for retrieving large sets of documents. This includes setting the size of each page, the number of documents per page, and the strategy for navigating through multiple pages. Challenges and fixes. Challenge 1. This challenge arises when the query string used to search for documents is incorrectly formatted, or when some required fields are missing. For example, if a query is expected to include a specific field name, but the query string omits this name, it can lead to unexpected or incomplete results. Similarly, if the query string syntax does not comply with the rules of Elasticsearch query language, it can cause the query to fail or return inaccurate results. Fixes to challenge 1. To address this challenge, carefully review the query string syntax to ensure that it adheres to the Elasticsearch query language rules. Additionally, verify that all required fields are present in the query string. Use the appropriate field mappings to ensure the correct interpretation of fields within the retrieved documents. This involves mapping the fields in the documents to the desired format in the output. Challenge 2. This challenge arises when there are authentication issues while trying to access the Elasticsearch server. This can occur if the provided credentials are incorrect, if the user associated with the credentials lacks the required permissions to access the Elasticsearch server, or if the Elasticsearch authentication configuration is not set up correctly. For example, if a user tries to access a secured Elasticsearch server with an incorrect password, the authentication process will fail. Fixes to challenge 2. To address this challenge, double-check the provided credentials for accuracy. Ensure that the username and password are correct and that they are entered without any typos. Verify that the user associated with the credentials has the necessary permissions to access the Elasticsearch server. This may involve checking user roles and permissions within the Elasticsearch configuration. Ensure proper configuration of Elasticsearch authentication. This may involve verifying the settings for authentication mechanisms such as basic authentication, token authentication, or certificate authentication, depending on the chosen security method for Elasticsearch. Scalability. Elasticsearch offers distributed capabilities that allow scaling to handle large datasets and high throughput demands. This can involve using multiple nodes or shards to distribute the load and ensure efficient indexing and searching. Langchain Elasticsearch Retriever. This YAML document provides a detailed explanation of langchain Elasticsearch Retriever, a tool for retrieving information from Elasticsearch indexes. It outlines the description, inputs, outputs, steps, prerequisites, fine-tune parameters, and challenges along with their fixes. Langchain Elasticsearch Retriever is a powerful tool that allows you to access and retrieve documents from Elasticsearch indices. It acts as a bridge between langchain and Elasticsearch, enabling you to leverage the search capabilities of Elasticsearch within your langchain applications. Inputs. The query string is a text-based input that represents the information you are searching for. For example, what are the benefits of using Elasticsearch? Or find products related to fitness. The Elasticsearch client is a connection to your Elasticsearch instance. It provides the necessary methods to communicate with Elasticsearch and execute search queries. You can use libraries like Elasticsearch DSL or Elasticsearch PY in Python to create this client. Outputs. The outputs are the documents that match your search query based on their relevance to the query. String. These documents are retrieved from the Elasticsearch index and returned as a list of relevant documents. Steps. The first step involves defining a query string that accurately describes the information you are searching for. This string should be clear, concise, and relevant to the data in your Elasticsearch index. The next step involves connecting to your Elasticsearch instance. This requires providing the necessary credentials and configuration information, such as the Elasticsearch URL, port, and any authentication parameters. Once connected, the query is sent to Elasticsearch. This is done through the Elasticsearch client, which handles the communication between your application and the Elasticsearch instance. Elasticsearch processes the query, analyzes the data in your index, and returns a list of documents that match your search criteria. These documents are then processed and returned as the output of the langchain Elasticsearch retriever. Prerequisites. An Elasticsearch instance is a running server that stores your data and allows you to search through it. You can set up Elasticsearch in various environments, including Docker. You can use Docker to run Elasticsearch in a lightweight containerized environment. AWS Amazon Web Services provides a managed Elasticsearch service called Amazon Elasticsearch Service Amazon S. Azure. Microsoft Azure offers a managed Elasticsearch service called Azure Cognitive Search. GCP Google Cloud Platform provides a managed Elasticsearch service called Google Cloud Elasticsearch. An Elasticsearch index is a collection of documents that share a common schema or structure. The index contains the data that you want to search through, such as product descriptions, news articles, or customer reviews. Fine-tune parameters. The K parameter specifies the number of documents to retrieve from Elasticsearch. It represents the top K most relevant documents based on your query string. The similarity score cutoff is a threshold used to filter out documents that do not meet a certain level of relevance. This parameter ensures that only the most relevant documents are returned in the results. Challenges and fixes. If you encounter an error connecting to Elasticsearch, several potential solutions can help troubleshoot the problem. Verify that your Elasticsearch URL is correct. This includes the hostname or IP address, port, and any necessary prefixes or suffixes. Check the credentials used to connect to Elasticsearch. Ensure that the username and password are accurate and have the required permissions to access the index. Verify that your network connection is working correctly. Check for network connectivity issues that might prevent your application from reaching the Elasticsearch server. If your query does not return the expected results, you can try the following. Refine your query string by making it more specific or using different keywords that accurately represent the information you are searching for. Consider stop words, which are common words that often do not provide useful information for searching, e.g. the, a, and. These words can be removed from your query to improve search results. Analyze the structure of your Elasticsearch index to understand how the data is organized and how the search engine interprets your queries. Optimize your search parameters. such as the similarity score cutoff or the number of documents returned. To improve the relevance and efficiency of the search results. Performance issues can occur when searching through large datasets in Elasticsearch. Here are some strategies to address these issues. Optimize your Elasticsearch index by ensuring that the data is properly indexed and analyzed for efficient searching. Tune your query string to make it more efficient, potentially by using query hints, field weights, or other query optimization techniques. Leverage caching mechanisms to reduce the amount of data that needs to be retrieved from Elasticsearch repeatedly. Consider alternative indexing strategies, such as using different document types or field mappings, to improve the performance of your Elasticsearch instance. Langchain Elasticsearch Vector Stores. Elasticsearch Store Summarization. Elasticsearch Store is a vector store that stores embeddings and documents in Elasticsearch Index. It allows for efficient retrieval of documents based on semantic similarity, making it suitable for tasks like question answering, document search, and recommendation systems. Inputs. Text. The textual content of the document being stored in the vector store. For example, this could be a news article, a product description, or a customer review. Embeddings. Numerical representations of the textual content. These are typically generated using a pre-trained language model like BERT or Roberta and represent the semantic meaning of the text. Outputs. Document the original text that was stored in the vector store. This can be retrieved based on its embedding or using a query that matches its content. Embeddings. The numerical representation of the retrieved document. This can be used to calculate similarity to other documents in the vector store. Steps. Create Elasticsearch client. Establish a connection to the Elasticsearch server using a suitable Python library like Elasticsearch Python client. This allows your application to interact with Elasticsearch. Create Elasticsearch index. Define a new index in the Elasticsearch server to store the embeddings and documents. This index will be specifically tailored to hold the vectorized data for your vector store. Store embeddings. Store the generated embeddings for each document in the Elasticsearch index. This involves indexing the embeddings as numerical data points associated with their corresponding document IDs. Store documents. Store the original text content of the documents in the Elasticsearch index. This could be done in a dedicated text field, enabling retrieval of the full document. Retrieve embeddings. Retrieve the embeddings of documents based on a given query. Elasticsearch uses its indexing and search capabilities to efficiently find the most relevant embeddings. Retrieve documents. Retrieve the original documents corresponding to the retrieved embeddings. This enables accessing the full textual content of the documents identified based on their embeddings. Prerequisites. Elasticsearch Server. This is a distributed, open-source search and analytics engine that can be hosted locally or in the cloud. It provides the necessary infrastructure for storing and retrieving the vectorized data. For instance, you can utilize a managed service like Amazon Elasticsearch Service or run it locally on your machine. Elasticsearch Client. A Python library like the official Elasticsearch Python client provides the interface for communicating with the Elasticsearch server. This library allows your application to send requests, receive responses, and manage the Elasticsearch index. Fine-tune parameters. Index name. The name of the Elasticsearch index where the embeddings and documents will be stored. This acts as a container for your data within the Elasticsearch server. For example, you could choose a name like Document Embeddings. Embedding field. The name of the field in the Elasticsearch index that will store the embeddings. This specifies the location within the index where the numerical representation of the documents is stored. An example could be embedding vector text field, the name of the field in the Elasticsearch index that will store the original text. This field holds the full text content of each document, allowing retrieval of the original textual content based on the embeddings. You could choose a name like document text. Challenges and fixes. Index creation errors. These errors can occur due to configuration issues in Elasticsearch or insufficient permissions. To troubleshoot, check if Elasticsearch is running properly. Verify the configuration settings of the index, and ensure that your application has the necessary privileges to create the index. Document retrieval errors. Document retrieval issues can arise due to incorrect query parameters or indexing errors. Verify that the query parameters match the indexing schema. Check for typos or errors in the search terms, and examine the Elasticsearch logs for any indexing errors. Langchain Elasticsearch Vector Stores BM25 Retrieval Strategy. This retrieval strategy leverages the BM25 ranking algorithm to retrieve relevant documents from Elasticsearch vector stores. Inputs: the text string that describes the user's intent or query. For example, what is the capital of France? The name of the Elasticsearch index that contains the documents to be searched. For example, knowledge base. Outputs: a list of documents ranked by their relevance to the query. This list typically includes a document's ID, score, and other metadata. Steps: the retrieval strategy receives a query string from the user. The strategy then sends the query string to an Elasticsearch server, which searches the specified index. Elasticsearch uses the BM25 ranking algorithm to determine the relevance of each document to the query and returns a ranked list of documents. Prerequisites: a running Elasticsearch server instance. Elasticsearch is an open-source search and analytics engine, commonly used for indexing and searching data. The instance needs to be configured and have the necessary indices set up. An Elasticsearch client library installed and configured on the system where the retrieval strategy is running. This library allows the retrieval strategy to communicate with the Elasticsearch server and send queries. Fine-tune parameters. The K1 parameter is used to control the impact of term frequency on the document score. A higher K1 value indicates that term frequency has a greater influence. This parameter can be adjusted based on the specific characteristics of the index and the desired level of precision. The B parameter controls the impact of document length on the document score. A higher B value implies that longer documents are penalized more heavily. This parameter can be fine-tuned to account for variations in document lengths within the index. The IDF parameter stands for inverse document frequency. It reflects how common a term is across the entire collection of documents. A higher IDF value signifies a rarer term, which typically contributes more to the relevance score. Challenges and fixes. Low relevance scores might occur if the BM25 parameters are not optimally tuned for the specific index and query characteristics. Adjusting the BM25 parameters like K1, B, and IDF can help improve the relevance scores. Experimenting with different values based on the data and query patterns is essential. Slow retrieval times may arise due to an inefficiently configured Elasticsearch index. Optimizing the Elasticsearch index by analyzing and improving its structure, data types, and indexing strategies can significantly enhance retrieval speed. Insufficient document retrieval could be a result of a poorly crafted query string. The query string should be carefully constructed to effectively capture the user's intent. Refining the query using more specific terms, synonyms, and Boolean operators can help retrieve more relevant documents.